alcohols are another class of functional groups we can deal with. Alcohols, you're probably familiar with ethanol and maybe methanol as well. So ethanol is used in hand sanitizers. It's also the byproduct of yeast fermentation. But alcohols, there's many different classes, okay? So there's many different types of alcohols, and all of our naming rules still apply. So you can see I gave you two examples there. Methanol, you can probably tell how many carbons are in meth and all, and then ethanol as well. So alcohols are characterized by a presence of this OH group, which is sometimes referred to as a hydroxyl group. Alcohol, again, we've got a parent hydrocarbon chain, and if you have propane, you can start to have some structural isomers being formed, right? So there's different structural formulas for anything like propanol, for example. So let's start with this. So we're going to draw propane, and then I want you to draw propane out, just normal propane, and I want you to erase a hydrogen atom and replace it with an OH. Now the carbon bonds to the oxygen, and then that oxygen will bond to another hydrogen. So I want you just to start with that, and I want you to pause the video right now and draw propane, erase a hydrogen atom that's there, any hydrogen atom, and replace it with an OH, okay? Here are some of the examples you could have done. So what I did in this one on the left is I drew normal propane, I erased this H that's there, and I attached the OH group with the O being attached to C. This is an alcohol. Here is another alcohol example. So again, 3 carbon in the chain, I erased an H and I put in this OH group, and this one up over here did the exact same thing I just chose there. There's lots of different options here, just 3. But the question is, which one of these is the same? Okay, so if you look at the structures of these, actually 2 of them are exactly the same, which is kind of crazy to think about. Let's go through these. Okay, here's the first one that was on the left. So how we name alcohols, the thinking surrounding it is we always want to identify what is the longest chain. In this case here, the longest chain has 3 carbons in it. So 3 carbons, that gives us prop. The next thing is, okay, how are these carbons connected? Is it single bonds, double bonds, or triple bonds? In this case here, all single bonds, so this is ane, right? So single bonds gives us ane. What carbon is the OH group attached to? Well, in this case here, we always want to make sure that we number these so that we have the lowest possible number. So this case here, I'm going to number this carbon, carbon 1, carbon 2, carbon 3. So the OH group is attached to carbon 1, so the first carbon. So what is the ending of alcohols? Alcohol, the word alcohol ends in OL. Alcohols end in that OL, okay? So what is the name of this? So we put all this thinking together. Well, the name of this compound is 1-propanol. Again, notice all the color coding here. Everything in the name means something. The 1 is referring to the alcohol, the OL. Prop means 3. This an means single bonds. 1-propanol. Let's look at the second example here. So the thinking of naming all of this is very similar. What is the longest carbon chain? It's still prop. We've got 3 carbons. Is it single, double, or triple bonds? In this case here, it's single bonds, ane. What carbon is the OH group attached to? This case here, it's the second carbon. So the name is going to change. The ending of alcohols is still OL. It always is OL. This is 2-propanol. So again, a little bit different of a naming. Now, notice this 2-propanol is a structural isomer of 1-propanol. They have the same formula, but they have different, they're kind of put together in a different way. So which one of these are the same? It was the ones on the left and the right. Notice both of these would be named 1-propanol. Again, it's important to number the carbons to the lowest possible number combination. Here, number 1, 2, 3. This one's not 3-propanol. What we do is just number this carbon 1, 2, 3. We always want to have the lowest possible number. So both of these are exactly the same. Both of these would be named 1-propanol. Now, some of the properties of alcohols, due to the polar hydroxyl group, alcohols are soluble in water. So again, remember, water is a polar solvent, and that OH group makes those compounds slightly polar as well, so they're able to dissolve in water. So if you've ever seen an adult mix a drink made out of a spirit like vodka, vodka is 40% volume to volume. So there's in 100 milliliters of vodka, there's only 40 milliliters is the ethanol. The other 60 would be mostly water and other flavor compounds. Alcohols can burn. So you've probably seen that in some gasoline that says it contains ethanol. So sometimes as an additive in gasoline, they add these alcohols in to the gas.